When factoring cubes, it's very similar to when we're factoring the difference of squares. What we have to do is, in investigating each one of these, we have to make sure that all of our terms, the first and the second, are perfect cubes. Remember, the perfect cubes mean that I can take the cube root of this and get a nice whole pretty integer number. So if you don't remember, sometimes it helps to say, well, 1 cubed is 1, 2 cubed is 8, 3 cubed is, oops, that's cubed, is 27, and so forth. And here's a complete list of the perfect cubes up through 10. So what we're looking at each one of these, if you notice that we have perfect cubes and that I can take a third of the exponent and I can take the cube root of 27. So the cube root of 27 is of course 3. The cube root here of 64 is of course 4 because it's from here, from this chart here. So each time what we're going to do is we're going to acknowledge what is A and what is B. So when we're factoring this, we're paying attention to this part of the equation. So when we're figuring this out, we have to figure out what got cubed. So if x squared is, x cubed is the first term, that means A is the cubed root of it. If 22nd is the second term, that means B is the cubed root of it. So I'm going to do another one on the setup. This is, we need both of them to be perfect cubes. A is going to be x, B is going to be the cube root of 64. Looking at this next one, A is going to be the cube root of both, so the cube root of 8 is 2. The cube root of x cubed is x. Then I have B, which is the cube root of 1, which is 1. So that's the first thing we have to do, is identify the A and B. And then what we simply do is, once we've identified whether it's sum or difference, which we can see quite plainly, then we have to simply plop everything in. So looking at 37, we have this acronym. We just have to know what A and B are, and then this SOPS, or same, opposite, sum. So if that's something, some people have different acronyms for remembering it, but I remember this as same, opposite, oops, that's too many P's, and then sum. Meaning that when I'm looking at this, if I'm looking at the sum of two cubes, then that means this first operation is going to be the same, this one is going to be the opposite of the original, and this one is going to always be the sum. So when I'm looking at the difference, this is going to be the same sign, the opposite sign, and then it's going to be the sum. So I'm plopping everything in here. So in order to do this, we have same, opposite, sum. And I might not have left myself enough room right there, so let's make that a little wider. And then we plop in the next one. It goes A, which is from our values over here, so A, B, and this is A squared. I said squared, not cubed, silly. And then this is A times B, so X times 3, and this last one is B squared. So we've plopped everything in, and of course this is not looking really pretty. So we're going to clean this up a little bit. So I've got x plus 3, this is x squared, and then x times 3 is obviously 3x, and then 3 squared is 9. And that is how we factor the sum or difference of cubes. So let's look at it again. We said that when we have perfect cubes, I can make it a little bit wider here, it is the same, opposite, sum. And then we do the same thing here. A was x, so A, B, and again I'm following right here this formula here. A squared, then times A times B, and then B squared. And then let's clean it up. So it's x minus 4 times x squared plus, well, x times 4 is 4x. We like that to be a little cleaner this way, and then 16. But what happens if it's something a little bit different? So let's look here. We have the same thing, it's minus. So when we set it up for the first time, it's same, opposite, sum. So A is 2x, B is 1, A is 2x, but be careful we don't just do this. It's not 2x squared, it's squaring the entire thing. And that will make a huge difference. It's not just 2x squared. When we square that, I'm going to end up with something a little bit different. And then this is A times B, and then B squared. So what difference does that make? Because if I didn't write the parentheses, I would have just written 2x squared here. But I did have the parentheses around it. So this is going to be 4x squared. I'm squaring everything. So this is 2 times x, 2x times 1, which is 2x. And this is going to be 1 squared, which is just 1. So pause the video for a moment, see if you can't figure out what a and b are for these ones, and then I will put up the answers. So in this we have all the answers written out here. Each time I would again figure out what is a and b, and then we would put it into the same opposite sum, same opposite sum. Now I want to bring your attention here to number 41. I'll highlight it, not cross it. What we looked at is, if I looked at this at the foreground, I'm like, oh, 250 is not a perfect cube, neither is 128, so it's not factorable. But what we haven't talked a lot about is the fact, remember, that anytime I go to factor something, I have to look for the greatest common factor first. So in this, they both have a 2 in common, so I factored that out. They both have an x cubed in common, so I factored that out. So when I'm looking at the values that I'm choosing for a and b, it has to be from what remains here in the parentheses. So the a is not going to be the cubed root of 250, it's going to be the cubed root of 125. Same thing for b. It's not going to be the cubed root of 128, it's going to be the cubed root of 64. So that creates what my a and my b are. The other thing I have to remember it's a squared, I'm going to write that here, a squared, this is ab, and this is b squared. So we have to make sure that we're squaring the proper thing. So it's not just 5x squared, it's not 25x squared, it's the whole entire thing. And I actually realized that I forgot to put a square here because we're squaring the 5x squared, which becomes 25x to the 4th. And then we're putting all these other values in it, and this is how it works out. The other thing to keep in mind is that the cube root of any exponent is simply dividing the exponent by 3. And so that's how, again, we're going to follow this one out.